one is on cylinders and quadric surfaces. So quadric surfaces are like your 3D version of of parabolas, of hyperbolas, of ellipses and circles. And so let's just do this with some examples before we do anything else. So sketch, here's one we know how to do. What does that represent? Well, a sphere, right? So a sphere, what's the radius? Where is it centered? 0, 0, 0. So I just going to draw it like this. Okay. You don't need to have great pictures of it, but hopefully that's the idea. Centered at the origin, right? So there's our sphere. You can decide where stuff is behind what. I'm not going to. All right. What happens if I just do that? So you may or may not have seen this before. Somebody probably at least mentioned it, but maybe you didn't pay that much attention. So if that was just x squared, what would I have? You'd have a sphere of radius 1 centered at the origin, right? So what's doing x minus 1 do to it? Think back to, yeah, it shifts it, right? Think back to when you were just working with functions and you did, y equals f of x plus 3. It shifted it to the left 3 units, right? So this just shifts it 1 unit in the positive x direction, right? And so this should be a sphere now centered at 1, 1, 0, 0. So centered right there and of radius 1, and so it's going to come out to, what, 2? And then you're going to just get, that's terrible looking. Oh, you get the idea though. There's a little ball right there. I'm not too worried about you drawing beautiful pictures. But hopefully you get the idea. That looks terrible. Let's pretend that we don't see that. All right. So our biggest thing isn't necessarily that you get these beautiful pictures going on, right? But it's that you can kind of see where these things are in your mind. Use a little bit of a picture to get there, but then also use your mind. Okay, let's do another one. X squared plus y squared equals 4. What's the graph of that equation? Okay. Circle of radius 2. So that's in the xy plane. What if I told you I want this curve, but in 3-dimensional space? So what should that look like? I like that. Yeah, up and down. Stretch it up and down. So if you have trouble visualizing this, just think of this first. So in two dimensions, if I say, what's the graph of x equals 3, what do you graph? A vertical line at 3, right? So x is 3 and y is anything, right? So we get that whole vertical line. Similarly, if I said y was -2, I get -2 is y and x is anything, right? And so here, if we're in 3-dimensional space, I'm telling you your x and y values satisfy this, right? And z is anything. So you draw what you would get in the xy plane, and then z is anything, so you pull it up and down. So you get a little circle there, right, of radius 2, and then I'm just going to go up with it. Right? And more or less like that, and then you get that little. So it's a cylinder being pulled up. Does that make sense? And so this section is called cylinders and quadric surfaces. And so anytime you have an equation and you just have 2 of the variables showing up, in this case x and y or x and z, you'll get a cylinder. And that just means you got a curve in your one plane and then it just gets pulled along right? And this is enough. We see this, we know it goes up and it goes down, right? As far as you want. Just draw whatever is a convenient little bit. So let's try a couple more of these. Let's do, actually, let's just do x squared first. Our life's easy for a minute. So, z equals x squared. Again, for the rest of this section, every graph is in three-dimensional space. So we're not going to bother with the simple one. So this will be a curve in the xz plane, right? Draw the curve, your normal z equals x squared curve you would draw, and then you just drag it along the y-axis, parallel to the y-axis. So try that for a second, and I'll give you one more here. Let's just do, let's just do z is sine of y. So, first one, what's z equals x squared look like in the zx plane? So again, x, y, z, right? So in the zx plane, that's just a parabola. Right? And so it should start here and just be like this, right? So this is in the plane sort of coming out of the board here. And then we just pull that this way, right? So just take it and go. Here, let me keep this piece lower. Do this. Right, so then this will be dragged and it'll be in front of all that, right? And then you'll get. And then you maybe want to just throw a couple extra lines in there just to make it clear what's happening. Does that make sense? So it's just a ribbon. Whatever your curve is, you just think it's like a ribbon of that curve. Hold along. And you don't have to draw, giant pieces of it. Just draw a little bit. What about this one? So what's your sine? So z equals sine of y. So in the yz plane, it's just the sine curve. So just to make sure we get enough of it, let's draw one little piece of it. You got that sine curve, right, in the yz plane, and then this time we pull it to the x-axis, so that means out of the board, right? And so do the same thing here. Just pick some interesting points and just think I'm going to drag those all that same distance. So this, right, and go parallel to the x-axis. You don't have to be perfect. Just try to go parallel to the x-axis and drag sort of some of those interesting points that same distance. Does that make sense? And then you'll just try to draw your sine curve there. I don't think you did a very good job on that first one, especially. And you'll just go like this, then, right? But hopefully you get the idea, right? There's just that ribbon of that curve coming out. And again, the big thing with us, for us, isn't that you can draw beautiful curves. Computers can draw great graphs now, right? You throw this, put this into Google even, it'll throw up a 3D graph. You got to somehow indicate that you want the 3D version, but it'll pop up a really nice looking graph that you can move around and look at. So, I mean, the ability to draw them by hand is less important now than it ever was, but we do want to be able to get rough sketches so that we can visualize things, because we're going to do volumes like you did before, and so if you got some surface here, you want to realize that's above. Beautiful picture there. Some surface down there, right? And so if you want the volume between those, you know this one's on top of this one, right? And so that's basically all we need to be able to do is get rough sketches so we know sort of relationships between curves or between surfaces, so we can pull that stuff off. Okay. So, like I said before, these are all called cylinders, where you just drag them in one direction. They're just usually functions where one of the variables doesn't show up. And then next time we'll talk about spheres, ellipsoids, and some other things. But let's stop there for today.